Alright, so chances are you clicked on this video because you want to see me fail at making a tutorial. Okay, so chances are you clicked on this video because you want to learn game development. Well, you've come to the right place. By the end of this series, you will have made this game, a little physics-based endless runner. You will have created a score system, player movement, and endless obstacle generation, as well as just making your game look nice. If that intrigues you, then let's get this road on the show. First thing we have to actually do to get this up and running is download the Unity game engine, which is what we'll be using to create our game. If you didn't already know, a game engine is sort of a framework for games. Sometimes creators will create their own game engines, or in our case, we'll be using a pre-made engine. Now, what do I mean by framework? Well, in our case, it takes a long time to write our whole physics system. But Unity's already taken care of that for us, so we can just focus on our game. Some popular game engines you might have heard of are Unity, which is what we'll be using, Unreal Engine, which is made by Epic Games, and Game Maker Studio 2. Each game engine has its strengths and weaknesses. No game engine is really better than another, but I really only know Unity, so we're just gonna go ahead and use that. Unity uses the C# programming language, which was developed by Microsoft. Unity also doesn't come with an internal code editor, so we're going to have to download one of those too. So, let's get downloading. In your search engine of choice, type in download Unity and then click the first result. Then, click on download Unity Hub. After it's done downloading, go through the whole installer and make sure you have it saved in a place where you can access it. Okay, so as stated before, Unity doesn't have a code editor built in, so we're going to have to download our own. In your search engine of choice, type in download Visual Studio Code, and click the first result and go ahead and download that. Once again, go through the whole installer, and I would recommend creating a shortcut for your desktop. Alright, so shocker, we have to make another download. So head over to your search engine and type in download.NET Core SDK. This will give Visual Studio Code added support for Unity and C#. Now that Unity Hub is installed, we actually have to install a version of Unity. Head down to Installs, click Add, and then select the newest version of Unity. Hit Next, and then add Linux, Mac, and WebGL build support, as well as the documentation. Next, we have to configure Visual Studio Code for Unity and C#. So, go over to the Extensions tab, type in C# and install the first result. Next, in the Extensions tab, type in Unity Tools, and once again, download the first result. Finally, I want to make Visual Studio Code look nicer, so type in Simple Dark, and go ahead and install that. After Unity is done installing, which by the way, you can check in the Installs tab of Unity Hub, head over to the Projects, click New, and select the 3D template. Give your project a name, and then select a location for Unity to save this project. I just stick them in a folder under my desktop. Click Create, and Unity will start building project. When Unity's done building your project, you should be in the editor. All of this looks very intimidating right now, but I'll try to make it simpler. On the left is the hierarchy, which contains our scene and the two objects that are currently in it, the main camera and the directional light. Next, on the right, you can see the inspector. If you click on different objects in the hierarchy, you'll notice that they appear in the inspector, which allows us to edit properties about them. Don't worry about any of the components right now, just focus on the transform component, which every game object has. You can adjust the position, rotation, and scale of each object. The game view is what our game will look like when we're playing it. We can click the play button here to start our game, the pause button to pause, and the play button while we're playing to actually stop the game. Next, we can head over to the scene view, which shows, well, our scene. Notice how when I select the main camera, a little gizmo appears. This will allow me to move the camera, as well as rotate it, scale it, which will do nothing because it's a camera, or do the latter. Also notice, when I have the main camera selected, and I go into the transform component in the inspector, I can change its values from there as well. Also, notice how when I have the main camera selected, I can see the game view. Everything that the camera sees is what our game view sees. You can right click to rotate in the scene view, And if you zoom out a little bit with the mouse wheel, you can see the whole camera's view. Anything we put inside of there will be seen by the camera. Finally, the last two tabs are the project tab, which contains all the files and assets inside of our project. Finally, we have the console tab, which will show us errors and warnings throughout our code. It's important that you check this every so often, because if you have errors, you can't actually run your project. If you ever mess anything up or accidentally delete tabs, just go over to the layout and then select the default layout again. Now, what do I mean by messing things up? Well, in Unity, the whole editor is completely customizable. You can resize windows, drag windows, even create new ones. If you ever want to delete a tab, just right click and click Close Tab. Most Unity developers have different layouts for different types of projects. As an example, I have one called Laptop, which I use for a single monitor setup. In this, I've resized and moved windows and added the animator and animation windows. For the purposes of this tutorial, I'm just going to stick with the default layout. Alright, now let's start doing stuff. First, let's create a cube. We can do this by going into the hierarchy, clicking 3D object and cube. I'm just going to rename this cube to player. You can do this in the inspector, or you can right click in the hierarchy and click rename. You'll notice that in the scene view, well, we have a cube. We can scale, rotate, or change its position. You can always undo changes that you've made with Ctrl and Z or Command Z on Mac. This cube, you'll notice, has three components other than the transform: the mesh filter, mesh renderer, and box collider. Let's go through these components. The mesh filter actually shows our cube. The mesh renderer holds all of the data that will help us render the cube. As an example, the materials. Without this information, we get nothing. The third component here is the box collider, which will allow us to collide with other colliders. Next, right-click in the hierarchy again, head over to 3D object, and we're going to create another cube. Let's drag this cube down to about -1, and we'll scale it out on the x-axis to about 20 and about 50 on the z. Now this all looks really ugly. I'm gonna go over to my directional light, change the color to a nice white. Still looks ugly, but we'll fix that later. Let's head back over to our cube and rename this to floor. If you head on over to the game view, you'll notice the camera's view of our player is really bad. So I'm just gonna push it back on the Z, push it up on the Y, and I'm going to rotate it down quite a bit. While we're at it, I'm also going to decrease the field of view on the camera component to about 40. I think this looks a lot better. There are a couple more things we can do to make this look a lot better. First, I'm just going to move my player down to about -5 on the Z. Next, we're going to give each object their own material. Right-click in the project and head over to material. I'm going to name this material player. Under the albedo tab, which is the same thing as the color, I'll click on that and select a nice blue for my player. Once that's all done, I can click and drag on the player material and just drag it onto the player. Another way I can do this is heading over to the scene, clicking and dragging on the material, and just assigning it to the player like so. The final way I can actually do this is clicking on the player, going over to the mesh renderer, and changing the material to player. Notice if the object doesn't have a material, it turns into an ugly pink. So make sure that every game object is either using the default material or just some other material that you've created. Finally, if you go into the scene view, look at the sky, it looks really ugly. What we're going to do is actually change that. Right click in the project, click create, and create another material. We'll name this Skybox. Up here where it says shader standard, we're going to click on standard, head over to Skybox, and we're going to create a procedural Skybox. You can change these values to anything you want. I'm only going to change the ground to a nice blue. If you look into our scene or game view, you'll notice there's actually no difference, but we can change that. Head over to window, rendering, and then click lighting, and then click lighting. As you can see, this will generate the lighting tab, which we can of course dock or drag around. I'm just going to stick it next to the inspector. Click on the environment tab and change the Skybox material to our newly created Skybox. The final thing we can do to not make this look like MS Paint the game is head over to our directional light, change its mode to real time, head over to our lighting tab, and then click generate lighting. This will improve the quality of our lighting because it allows Unity to calculate the balances of each light source. Now if you go into the scene or game view, you'll notice that it looks a lot better. We'll still be improving the look of it as we go, but we're going to focus more on programming in the next few episodes. And that's going to be it for today. Next episode, we'll start programming, so in the meantime, try not to get your computer destroyed. Thank you to all my subscribers, and see you next time.